Okay, question 10, part A. Here we have two more parametric equations for x and y in terms of t, and we're asked to find dy by dx at t equals 2. Okay, now looking at the terms involved, this 5 over 2t here is the one that we need to be a bit careful of before we start. So I'm just going to rewrite then the y equation as 4t plus 8 plus 5 over 2 t to the minus 1. Okay, then we're ready to differentiate it. We should know that dy by dx in parametrics is dy by dt divided by dx by dt. Okay, and so then we just go ahead. So differentiate the y function. So differentiate 4, we get 4. Differentiate 8, it disappears. Differentiate 5 over 2 t to the minus 1. Okay, that minus 1 comes to the front, of course, and then drops by 1 to go down to minus 2. Okay, then that's all divided by dx by dt, so differentiate the x function. Well, here differentiate 4t, you get 4. Differentiate 3, it disappears. And so that's what we're left with there. Bit of tidying up to do. Possibly, although I haven't said that we're substituting in t equals 2. So we're substituting in t equals 2, so we might as well do that straight away and then tidy up later. So we've got 4 minus 5 over 2, then sub in the 2. Okay. Now then you could try checking that through on a calculator, being careful to make sure that you leave it in exact form at the end. The 2 to the minus 2 should come out as a quarter, of course. Okay, so then what we've got there, so 5/8, 4 minus 5/8, 32/8 minus 5/8 all over 4. So that's 27/8 times by a quarter, leaving us then with 27 over 32. But those last few steps you could get away with doing on your calculator so long as it gave out the perfect answer of 27 over 32. Okay, question 10 part B. Here we have the same two parametric equations and we're asked to find the Cartesian equation. We're given a sort of structure for it. But one technique you could use here is to imagine you weren't given the structure for the Cartesian at all, and you were just trying to get the Cartesian. Well, here then you could rearrange this equation to make t the subject. Okay, so x minus 3. Taking the 3 across there and then dividing by 4. Okay, so that makes t the subject of this one. And then if you substitute it into there, then you would eliminate t. So I'm going to call that equation 1, call that equation 2. So sub 1 into 2 gives us y equals 4 lots of t, but t is now x minus 3 over 4 plus 8 plus 5 over 2t, but t is now x minus 3 over 4. Okay, so now the whole task just comes about arranging the algebra of this and trying to get it into the form. So trying to get it into the form x squared plus ax plus b all over x minus 3. So that's what we're aiming for. Okay, so let's see where we can take this. So here we've got 4 times x minus 3 divided by 4. Well, those 4's cancel, leaving us with simply x minus 3. Copy down the plus 8. So as you can see, a lot of work's going to be going on here. So initially what we could do is, well, we've got a multiplication by 2 there, we've got a division by 4 there, so they cancel down to an overall division by 2, so that's 5 over x minus 3 divided by 2. Okay, and then Oh yeah, so then minus 3 plus 8 is plus 5. Now then here, when we're dividing by a fraction, we flip and multiply, so 5 times by 2 over x minus 3. Okay, so 5 times 2 over x minus 3, well that's 10 on the top then. Okay, and we're sort of starting to get there. We've got a denominator of x minus 3, but we're aiming for a form where there's a common denominator of x minus 3, so that means we need to turn the x and we need to turn the x plus 5 into a fraction over x minus 3. So x, if we're going to make that a fraction over x minus 3, we'll have to multiply it by x minus 3 as well as divide it by x minus 3. Similarly with 5, we're going to have to multiply it by x minus 3 and divide it by x minus 3. And then we've got our fraction we already had there at the end. Okay, now we can merge them into a single numerator, so x bracket x minus 3 there, plus 5 bracket x minus 3 there, plus the 10, all over the common denominator of x minus 3. Okay, expand the brackets, we've got an x squared minus 3x there, got a 5x minus 15 there, and then copy down the plus 10. Okay, we're nearly there. Final step, just to tidy up that top, we've got x squared, we've got minus 3x plus 5x, that's plus 2x, we've got minus 15 plus 10, so that's minus 5, all over x minus 3. Therefore A must have been 2 and B must be minus 5.